this video, we will study the electrolytic and electrometallurgical process. So the contents are ionization, Faraday's laws of electrolysis, some definitions, extraction of metals, refining of metals, and electrodeposition process. So what is ionization? Ionization, it is a process by which an atom or molecule acquires charge. Negative charge by gaining electrons and positive charge by losing electrons. This process is in conjunction with the other chemical changes taking place. So when the atom or molecule gains or loses electrons, they become electrically charged and they are called as ions. So ionization, it can result from the loss of electron after collision with the subatomic particles or collision with the other atoms, molecules or ions, or due to the interaction with the electromagnetic radiation. In an electrolyte, the molecules of the substance dissolved are dissociated. That is, they are broken up into atoms and there results in a constant interchange of atoms between the molecules. Due to the interchange of atoms between the molecules, at any instant, there is large number of free atoms available. These free atoms, they are electrically charged. The metallic ones are positively charged and the non-metallic ones are negatively charged and they are called ions. So if the solution is more dilute, then greater is the dissociation or ionization. Since the ion is charged, the chemical and general properties of it differ from those of the same atom when it is free of charge. So let us see an ionization process. So we have copper sulfate dissolved in water. So we have the copper sulfate solution in the vessel. And two electrodes, one connected to positive of the supply and another negative of the supply. So two electrodes, one is anode and another cathode, negative one. So this copper sulfate solution will dissociate into positively charged copper ions and negatively charged sulfate ions. So the electrodes which are placed in the solution are positive, one is anode and one is negative cathode. So the positively charged copper ions, it moves towards the cathode and negatively charged sulfate ions, it moves towards the anode. And once they reach the electrode, they give up their respective charge and become ordinary molecule. So copper will be deposited at the cathode electrode as metal, whereas sulfate ions, it will be collected at the anode and it will react with the water, giving rise to oxygen. So the chemical reaction is sulfate reacting with water and liberating oxygen. Also sulfuric acid is formed. So oxygen is liberated at the anode and there is sulfuric acid formed. Suppose the cathode is made up of copper. The material used for the electrode is copper, then the sulfuric acid will react with it, forming copper sulfate and liberating hydrogen. So the sulfuric acid will react with the copper and produce copper sulfate and liberate hydrogen. So copper of the anode goes into solution and copper from copper sulfate is deposited on the cathode. So these chemical effects, they are made using electroplating, extraction of metals, refining of metals and manufacture of chemicals. Next is Faraday's laws of electrolysis. First law states that the weight of the substance liberated from an electrolyte in a given time is directly proportional to the quantity of electricity passing through the electrolyte. That is, W is proportional to Q or proportional to I into T, where I is the current and T is the time. Therefore, W is equal to ZIT, where Z is the proportionality constant known as electrochemical equivalent. If current I is 1 amperes and the time for which it flows is 1 second, then Z equal to W. That means the electrochemical equivalent of a substance is the amount of that substance by weight liberated in unit time by unit current. So this is expressed in milligrams per coulomb. So it can be converted into kilogram per 1000 ampere hours. So we have Z equal to W milligrams per coulomb. So it is converted to kilogram per 1000 ampere hours. So W into 10 to the power minus 6 into 3600 into 10 to the power 3 gives us 3.6 W kg per 1000 ampere hours. Next is second law. It states that when the same amount of current flows through several electrolytes, the weight of the substance liberated is proportional to their chemical equivalent. So the chemical equivalent of a substance, it is weight of the substance which can displace or combine with unit weight of hydrogen. So the chemical equivalent is given by atomic weight by valency. Next we will see few definitions. So first is current efficiency. So due to the impurities which cause secondary reactions, the quantity of substance liberated is less than the calculated from Faraday's law. So the current efficiency is nothing but actual quantity of substance liberated to the theoretical quantity of substance liberated. So the value, it lies between 90 to 98%. Voltage. The voltage which is necessary for the passage of current through an electrolyte, it depends upon the potential drop at the electrodes and in the electrolyte. So these drops should be as small as possible. So for this, some agent will be added to make the electrolyte a good conductor, thereby reducing the voltage drops at the electrodes and in the electrolyte. So example is dilute sulfuric acid is added to copper sulfate bath in copper plating. The normal voltage needed to pass current through most electrolytes is 1 to 2 volts. Next is energy efficiency. Due to the secondary reactions taking place, which is due to the impurities, the voltage actually required for the deposition or liberation of metal is higher than the theoretical value, which increases the actual energy required. So the energy efficiency is defined by theoretical energy to actual energy required. Next is extraction of metals. This is done in two ways. First one, the metal ore is treated with strong acid to obtain a salt, and the solution of such salt is electrolyzed to liberate the metal. Second method is when the metal ore is available in molten state, it will be electrolyzed in a furnace. So the table shows some of the processes. So for metal aluminium, the solution used is fused cryolite. For copper, the ore of copper is treated with sulfuric acid and the solution used is copper sulfate. For zinc, it is treated with sulfuric acid and the solution used is zinc chloride or zinc sulfate. Next we will see the extraction of different metals. So first one is extraction of zinc. The zinc ore consisting of zinc, it is treated with concentrated sulfuric acid and then roasted and then passed through different processes to get rid of the impurities. Then the zinc sulfate solution obtained is electrolyzed. The cells, which consist of large lead lined wooden boxes, have aluminum cathodes and lead anodes, and the current density required is 1000 amperes per square meter. So after the electrolysis process, zinc will get deposited on the cathode. Next is extraction of aluminium. The aluminium ore, it is bauxite cryolite. So this ore, bauxite, it is treated chemically and reduced to aluminium oxide, and then it is dissolved in the solution of fused cryolite and electrolysis process takes place. The furnace used, it will be lined with carbon and the temperature of the furnace is about 1000 degrees Celsius to keep the electrolyte in the fused state. Aluminium will get deposited at the cathode. Next is refining of metals. The extraction of metals use 98 to 99% pure metal. So further refining is done by electrolysis method. The anodes, they are made up of impure metal extracted from the ores, and the electrolyte is the solution of the salt of that metal. And after electrolysis, pure metal will be deposited on the cathode. So the table gives us the different solutions used for the different metals. So for copper, it is copper sulfate solution used for electrolysis, and for iron, it is iron ammonium sulfate, and for nickel, it can be nickel chloride or nickel sulfate. Electro deposition. This is the process where a metal is deposited over another metal or non-metal. So the common example for this is electroplating. Some conditions have to be provided so that the deposit is fine grained and has a smooth appearance. There are few factors which affect the appearance of the deposited metal. They are: first factor is current density. At lower value of current density, the ions, they are released at a slower rate, and the rate of growth of nuclei, it is more than the rate at which new nuclei are formed. Electrodeposition, it depends upon the rate at which the crystal grows and the rate at which fresh nuclei is formed. Therefore, at lower value of current density, the deposit will be coarse and crystalline in nature. Whereas, at higher value of current density, the quality of deposit becomes more uniform and fine grained due to greater rate of nuclei formation. Next factor is electrolytic concentration. This is more or less complementary to current density. Increasing the concentration of electrolyte will increase the current density. So, if current density value is high, then the deposit will be uniform and fine grained. Therefore, increasing the concentration will give us better deposit. Next factor is temperature. The temperature of the electrolyte, it has two contradictory effects. One is, at comparatively high temperature, there is more diffusion, and at relatively high current density, smooth deposits may be produced. Second effect is, at high temperatures, the rate of crystal growth, it increases the possibility of coarse deposit. Therefore, moderate temperature should be chosen so that the metal deposit is good. Next factor is additional agents. The quality of a deposit is improved by the presence of additional agents, which may be colloidal matter or an organic compound. Otherwise, the metal deposit will be in the form of large crystals, making the surface rough. So the materials used as additional agents are gelatin, agar, glue, gums, rubber, alkaloids, sugar. So the additional agents, they are supposed to be absorbed by the crystal nuclei so that it prevents their growth into larger crystals. The discharged ions, they start to build up new nuclei and hence the deposit of metal is fine grained. Next factor is nature of electrolyte. Smooth deposits, they are obtained from solutions having complex ions. Example, cyanides. So silver from nitrate solution forms a coarse deposit, while from cyanide solution forms a smooth deposit. Therefore, the formation of smooth deposit, it depends upon the nature of electrolyte used. Next factor is nature of the metal on which the deposit is to be made. This will influence the growth of crystals, since it is believed that the operation of crystals is in continuation of these in the base metal. Next factor is throwing power. The throwing power of an electrolyte, it is regarded as the quality which produces a uniform deposit on the cathode having irregular shape. So if the shape of the cathode is irregular, then the distance of the various parts of the cathode from the anode will not be the same. Therefore, the conductance of the electrolyte will not be the same for all parts of the cathode. So in an electrolyte of low conductance, the current will concentrate on the parts of the cathode which is nearer the anode and results in poor throwing power. So if the electrolyte has good conductance, then the throwing power will also be good. So to improve the throwing power, we have to keep a good distance between the cathode and the anode, thereby providing more conductance at all parts of the cathode, that is same conductance at all parts of the cathode. Also, presence of colloidal matter, it improves the throwing power, but it will also increase the temperature which will produce the opposite effect.